Welcome to Tarragona from CellSpex. Today I'm going to show you how to set up a fitting model which fits Lorentzians or Gaussians to your spectra, and then use that model online to measure the intensity and width of your peaks in real time. So I have a data set which is saved in your examples folder, so that's under Program Files, CellSpex-Espana, Tarragona Examples, and this is 05 peak fitting. And this data set is from a little neon indicator lamp which gives me a spectrum like this. And I've collected 100 spectra and I've just plotted out the intensity at 668 nanometers just to give me a time course. So first I need to create a fitting model and select what I'm going to fit. So fitting, new, and peaks is my fitting model. And now I'll select what I'm going to fit. So I could either select a plot from a graph, for instance this one, and then it would fit that plot and stop. Or I can fit the spectra from the study, and in which case it will fit all the spectra in the study and put the output into the data items. So I'm going to do that. I'm going to choose wavelength and intensity. So now I need to show my fit. So I'll take this graph and split it in two, clear that copy and put my fitting in here. View, the data, the fit and the residuals. And at the moment there's nothing in the fit, so the fit is the light blue, it's just 0. And now I'm going to choose what I'm going to fit. So I'm going to zoom in here. What I like to do is fit these three peaks. So these two are overlapping and this one's separate. So I'll zoom in again, and then I'll set the tick space into 1 nanometer so I can see what the wavelengths are. Okay, so now I'll edit my fit. So this lists the peaks I'm going to be fitting, and I first of all want to set the fitting range. So I'm going to set from 644 nanometers up to 665. Okay, and then I'll preview that, and it's here. So now I shall enter my peaks. I have 3 peaks. These two are not resolved in the third one, so I need 3 peaks. And this one is at about 651 nanometers. And it's about 20,000 counts high. This one is at 653-ish. And it's about 7,000 counts high. So this is just sort of giving me starting values, and this is at 660, and this is about 7,000 high again. And I have a linear background. So if I preview that fit, I can see that I haven't got a very good fit, but that doesn't matter because I'll now go ahead and fit the data. So I hit fit, and it fits to this one spectrum. And the residuals, which are the difference between the data and the fit, are not flat around 0. And that's because these are not Gaussians, but it's not a disaster. Okay, I now want to change the color of my peaks. So peak 1 is the shortest wavelength, I'll make that one blue. And by doing that here, it will save a little bit of time later. And I'll make this one green. Okay, and now I can fitting view, and I can now look at all my peaks, how these make up the spectra. So here's the short one, this one, and this one. Okay, so now what I would like to do is output the peak amplitude, the position and the width to a data item so I can fit my data and see how it varies with time. So I'll go into fitting parameters, and I want to look at the peak 1 position, and it's blue wavelength, peak 2 position and peak 3 position. And then I look at peak 1 width. You can actually do this in any order, but this will make it a little bit more convenient when I come to plot the data. And then the amplitudes. And the amplitudes. Okay, so now I'm going to clear this one, split this one into 3 rows, and I'm going to shift select them and put them on the same, so they have the same x-axis. And then in this one I'll plot out the positions because I selected them in that order, that order here. Data view, widths, and data view, amplitudes. Whoops. And as you can see, there isn't anything yet because I haven't fitted the data. So now I'm going to start my fit, and it will fit to all 100 spectra, and that's done. So I've timed this fitting, and this takes about 2.5 milliseconds per spectrum. So it's certainly fast enough for online fitting. And as you can see from my data, if I just scroll through here now, to look at the fitting at different times. You can see the spectra almost all the same, so that everything is constant. So now I've fitted my data, but I'm not ready yet to use this for online fitting, and I'll explain why. So if I go into my fitting model, so the way the model works is it will change the width a little bit, change the height and change the position, and see if it gets a better fit. And if it gets a better fit, it will change like that. However, if my peak is over here, so if I move this down to 646 nanometers, and I make it very narrow, and I'll preview that. Now you can see that it's completely missed the fit. And now if it changes the width or the position or the magnitude, it doesn't improve the fit at all really, and so this peak will get lost. So if I now fit that, it's gone. It's shot off to 644, so it's down here somewhere. So what I need to do is constrain my fit. I put it back at 650 and then fit that, and it's fitted. So what I could do would be to fix my widths and my positions. So if I click on it and hit the insert key, it goes grey to show it's fixed. And I'll fix those. But if I do that, then the fitting model won't be able to vary these to make the best fit to the data. And I won't be able to look at how my widths are varying. So my other option is to make it fittable, but to constrain it so it can only fit over a certain range. So you can see these are quite constant width. So if I allow them to vary over about a nanometer, the minimum 0.7 and the maximum 1.7 nanometers, it will only allow this to vary within this range. If I lose my signal, it will vary it to get the best fit, then stop at the minimum or the maximum. So I'll do that to all of them. So 1.1 and 2.6. And 0.8 and 1.8. Now, for my position, I have another trick. So I can fix my positions of all the peaks, but allow them to move rigidly. And I can do that with the peak shift. So if I set the peak shift to 2 and preview, you can see it's shifted all my peaks by 2 nanometers this way. So what I can do is I can put limits on my peak shift. So I need to make sure it's not fitted, and I can make this peak shift a minimum of 0.5 and a maximum of 0.5. And this will allow all the peaks to rigidly shift between minus and plus a half a nanometer. And this is also useful if your calibration changes during the experiment or between experiments, because it'll allow the peaks to shift just a little bit to get the best fit. Okay, so if I fit that, and there. Okay, and so now I'll fit and start. So now we're constrained, we're ready to go. So what I'll do is I'll start collecting data. And you can see that I'm fitting to my data. So if I change the intensity a little bit, and then I'll stop. But there's nothing happening here. If I now go fitting start, it will fit the data, and this is where I vary the intensity, but it's not online fitting. So this fitting here, when you go start here, this is for the offline post-analysis fitting. To get this to fit online, I need to take this fit, copy it to the clipboard, go into Acquire, Setup, and the fitting under my spectrometer tab, right click and paste it in. And now it will use this for online fitting. So now when I start data collection, you can see it's coming out now. And as I vary the signal by changing my fiber, you can see it varies in time. Yeah, like that. And this is just a representation of the fitting. I don't actually need this. So if I now go and close this, this is still working because this is the online fitting, this is separate. So I'll stop there, and if I want to get my fitting back, I can go Acquire, Setup, Fitting, copy that to the clipboard, cancel, cancel, fit in, paste this in, fit in, select the spectra again, intensity, fitting, view, data fit, residuals, peak 1, 2 and 3, and then we're back. Okay, I hope that was useful, and thank you very much.